So this panel is on CBRN, and we have a really terrific panel. So first up, we have Gary Ackerman, who is an associate professor in the College of Homeland Security, Emergency Preparedness, and Cybersecurity at the University of Albany, SUNY. And it's a brand new school. It's really exciting. I was hearing about it last night. He's also the founding director of the Unconventional Weapons and Technology Division at the National Consortium for the Study of Terrorism and Responses to Terrorism, which many of us in this room know as START. And he is still a senior advisor there. He has written a ton and has a really great background. We have a really terrific panel here. Our next speaker is, let's see, wait a minute, I have all these out of order, I apologize. All right, is Carol Kuntz, and she has served in the U.S. national security community for 30 years. Her work has focused on identifying changes in the strategic environment and implementing new policies and programs given to those changes. She has worked directly with the Undersecretary of Defense for Policy and the Secretary of Defense in crafting a new defense strategy and thinking about replacing the post-World War II strategy of containment. She's worked in a number of different areas and capacities in the DoD over the years, and is now, she actually, for 5 years after 9/11, served as Homeland Security Advisor to the Vice President, advising him on Homeland Security matters, and is now transitioning into a new career in academia and in consulting. And finally, we have, let's pull this up in a minute. Sorry, everybody. Where is it? Oh, wait, why did this all get out of order? Oh, here we go. Dan Kaszeta. And he has 28 years of experience in CBRN defense and emergency response issues. He started his career in 1991 when he was commissioned as a lieutenant in the U.S. Army Chemical Corps. He was an honors graduate of the U.S. Army Chemical School, and after a period of active service, he then went on to be a Reserve and National Guard chemical officer in employment with the civilian employment. He was CBRN advisor at the White House Military Office from 1996 to 2002, and a specialist, senior specialist with the U.S. Secret Service, totaling 12 years of work at the White House complex. I was just hearing about his book on nerve agents over lunch, which I'm really excited about reading. So without further ado, let's talk about CBRN.
Yes, I have slides there. Yeah, I think I have them. Good afternoon, everybody. Are we good, Chris? Thank you very much, Dr. Jordan and all of the other hosts. I think this is a very interesting, worthwhile conference to have, and it's one of those things that doesn't get enough attention. We hear a lot about CBRN, we hear a lot about terrorism, and we hear a lot about emerging technologies, but very rarely do we really look at the nexus between them. So today, I promised myself that I would wean myself off of PowerPoints, and I will do that, but not today. I'm still recovering. I'm falling off the wagon. But today I'm going to talk to you a little bit about, I'm going to give you a bit of a background on terrorism and technology, and I'm going to interweave CBRN concerns in there. So it might be a little bit broader, and I think that might be useful as a sort of background. So first thing to realize is that technology is always changing. We know that's happening. I'm not going to read out all the quotes, but this is a famous quote by the futurist Ray Kurzweil. But it sort of gets at the sort of exponential or greater changes in technology. And then again, there's another version of that where a lot of this it's not that it's only happening in 10, 20, 30 years' time. A lot of it is happening today. We just don't know about it yet. It's happening in some lab somewhere in the world, or some cave somewhere in the world, or some high school student's basement somewhere in the world. So that's kind of sort of a premise. The question that we're actually asking ourselves is, how do emerging technologies empower adversaries for CBRN? And that's kind of what I'm going to be looking at today. So there's a lot of emerging technologies. We've discussed some of them already, like drones, but I'm going to focus on the CBRN side of things. These are some interesting quotes. I like the one on the right-hand side. The best comes from an AI theorist, if anybody knows Eliezer Yudkowsky, but that's kind of a really pithy way of putting something. So how do we get, so before we answer this question, we have to know about what emerging technologies are there and what could possibly intersect with terrorism. So the first way of doing this is to sort of do what's called a horizon scan. And myself and colleagues have done 2 of these in the last couple of years, one on chemical and biological and one on radiological and nuclear. And the idea here is to try and survey the broad horizon of all potential technologies and try and somehow sift out those that have strategic relevance. So this is just an example of one of our horizon scans. You look at more than 1,000 sources, everything from mainstream literature and patents to fringe materials, TV shows, science fiction books, and everything in between. We then get what we call signal coding. We extract from that signals of potentially relevant information. We supplement that with expert input. We do input with experts all around the world. And we come up with a lot of clustering, and there's a whole lot of science or pseudoscience affiliated with actually putting this all together. And we come up with what we call clusters and then insights. And insights are the things that really matter. Like the one at the bottom there, you can't really see, but it says RN hobbyists. And it's talking about what RN hobbyists are going to be able to do with radiological nuclear materials. So at the end of it all, you put it all together and you get what's called a horizon. This is the way we show it now. I don't expect anybody to see all of that, but this sort of separates things. If you look at the middle, this is one for the radiological, it separates things from decreasing trends to stable trends to increasing trends, and then to what we call sort of the nonlinear dynamics, the discontinuities that are emergent issues, wildcards, and black swans. And I'm not going to go too much, I don't have time today to go too much into all the differences, but this just gets you an idea of how you position the space of what's happening. Now, just to save people the eyesight, that's just a zoom up on one of our nuclear ones, just a small section of the nuclear one. And each of those ends up being like an entry, and each of those ends up having a couple of pages of explanation and a whole lot of metadata. And the ones that are full circles are the ones that we think are going to have the highest strategic impact versus the ones that are half circles have a medium and the ones that are small circles have low. There's a whole lot of other metadata, but that's just a way of sort of seeing the whole space. So you can see where the most, if you look at the diagram, you can see that which sectors have the most dynamism. So that's kind of thing. Here's another one on the defense side for radiological. As I said, there's no time to go into all of these. I'll mention some examples as we go, but you get the idea of the basic process that's involved. So what did we learn from all of this? We learned a couple of things from all of this. I generally start out by being a person who says, do not be alarmist. Things are never as bad as they might seem, and don't go in the worst case scenario. But then whenever I do research, I prove myself wrong. So I end up becoming sort of a lot more afraid at the end of my research than the beginning. But the first thing about CBRN and the new technology vis-a-vis CBRN is that it lengthens the level of asymmetry for terrorists. So it allows them, and we've mentioned this before, to obtain weapons of mass destruction at a lower cost, lower footprint, lower risk, and requiring less training. And this goes into the whole idea of democratizing of WMD. So that's kind of the first thing that it does. There's a lot of different technologies that have the capacity to do this. Things like everything from additive manufacturing to certain new production techniques to certain synthetic biology, et cetera, et cetera. Another thing that these emerging technologies will do is that they allow us to overwhelm existing defenses. For example, if you can engineer a synthetic pathogen that it can get around vaccines and antibiotics, et cetera, et cetera. So the idea there is that it allows adversaries to kind of do an end run around current countermeasures that we've been developing over the last 50 years. Another element of the emerging technology is it can heighten the psychological impact of attacks. So we know chemical, biological, radiological agents are generally intangible, invisible, and often latent. And the idea behind this is emerging technology adds to the existing psychological frisson of this. And then the new technologies can actually provide entirely new ways to cause harm. For example, using nanoparticles or self-sustaining critical reaction devices. I don't know if anyone's familiar with those, but nobody's ever built one before as far as I know, but it's essentially midway between a nuclear weapon and a radiological weapon, and it basically just pumps out a whole lot of radiation. So you get kind of your own Fukushima or Chernobyl that you can build in your garage, and it's not quite as simple, but the technology is only get to the stage where it's feasible to do very recently. And this is the whole idea of, increasing terrorism itself is an asymmetric tactic. It's an asymmetric approach, and what this does is lengthen that lever. You can see this in historical perspective. This is just a small chart that I like looking at. If you look historically, this is a little contrived in the sense that looking at how many people can be killed with a single action of a human being, and it was sort of basically one when you're dealing with direct weapons, and it goes all the way up through history, and it's got to where you can destroy essentially the whole world with thermonuclear war. The question is, where are violent non-state actors like terrorists on this curve? Are they on the same curve? Are they shifted a little bit to the right? Are they in a completely different curve? And that's kind of the questions that we essentially care about when we start thinking about emerging technology and CBRN. Another element that comes out when you did a horizon scan, which is sort of well known as well, is the inherent dual-use dilemma. Emerging technology has dual-use aspects. Those who know history know that nerve agents came from pesticide research in the 1930s. And new pesticides are being developed all the time, some of them to be environmentally friendly, but a lot of these pesticides are having interesting side effects that could one day be, tomorrow's chemical weapons. So Fosmet, which is quite a well-known pesticide that's being used, has actually been shown to really mess with the heads of jumping spiders, and jumping spiders actually eat the bugs that eat the crops. Or the fruit trees. So it's actually doing damage, even though it does kill the bugs as well, it actually is messing with their predators. And if you see including autophagy, which they start eating themselves and things like that. So, I'm not saying that that's a harm to human beings, but I'm just saying kind of unintended consequences. There's been similar in the biological side. You have influenza gain of function debate, which has gone on with, can we mess with the influenza virus to understand it better, and with Fouchier and all that. I'm not going to go into that now, but it's been a debate. And more recently, the horsepox synthesis. They synthesized horsepox, which is not that different from smallpox in 2017. And there's sort of look at this is done, and there's a nice report that was done by Griffin Scientific on the risk and benefits of gain of function research. But this is kind of the idea that something that pops out with emerging technology, and it's a key issue. Another key issue is threat convergence. So CBRN, together with other technologies, is kind of converging. A lot of these, we all know that chemistry and biology and physics are kind of overlapping. They always have, but now they actually, not just theoretically, they're now overlapping in the lab, where they're using biological processes to produce chemicals and chemical processes to produce biological material, et cetera, but cyber with data analytics, chemical, bio, nanoscale, and AI autonomy, all of these can play off each other and have this intersection. Now, there's actually a lot more here, but this was just a nice diagram. So that's something you have to take into account with emerging technologies. There are a lot more, let's just say, have a lot more intersection and interaction with other types of technologies than might have been the case in the past. An example here is CBR plus drones plus SORM algorithms. So you take your sarin, you get a pesticide spraying system, and this is an old one. You can get one now that's got a 30 kilogram spray, and you can direct it where you want with GPS and have it deliver a very even application of GPS, and you get 50 of those, and you use swarm technology, which GTRI is actually one of the leaders in. And I'm trying to get drones that I'm working with in our drone lab to work with swarm technology, and most of the downloaded algorithms that I'm using are coming from GTRI. So thank you very much, but I hope that I'm the only one who knows about that. And there's been a paper written about this earlier this year on drone swarms and CBRN. So if you want to read that paper, it's a very interesting paper. But there's the other side of the coin. So another thing to remember is that technology being dual use, there might be a lot of dangers by technology, but it also has a lot of positive aspects. So for CBRN defense, and I'm not going to rain on the parade of my fellows, but I just want to give you one example of one of my favorite ones, because it's a cool story. This is sort of a British sort of anthropologist and historian of early warfare, said, there's a quote by him, and I actually like this, but we have to think about the other side of the coin as well. But one of my favorite stories in this is efforts to create bioscavenging enzymes as treatment for nerve agents. So these are enzymes that would stay in your body, theoretically, and would neutralize organophosphates, which is wonderful. It can make it happen. Unfortunately, they know what the enzymes are. They've got the enzymes. The enzymes don't survive very long because our immune system essentially obliterates them. So they want to try and create versions that can be tolerated by the human immune system. So essentially, it would function like a vaccine for nerve agents. But there's one problem. How do you produce that? So they've now genetically engineered goats, and they have mutant goats trying to produce milk with these enzymes in it. So, and the reason I'm telling you the story is because I just really like the picture of the mutant goat. It's not that kind of a mutant goat, but that's funny anyway. So there's some other examples of smart distributed ubiquitous sensors, autonomous sentries for nuclear facilities, and rapid vaccine production techniques. But I'll let you guys handle that. So, but the key takeaway here is emerging technologies will empower both the terrorists and the counter-terrorists with respect to CBRN. But Horizon scans revealed substantially more threat-related than defense-related insights. So the key strategic movements, there's far more on the threat side that we thought than on the defense side. So that was one of our takeaways. Okay, but then again, there's a need for more close investigation because that is kind of very theoretical. So the idea is we don't want to get caught within the trap of technological determinism, that we think that just because there's a new technology that terrorists are going to necessarily be aware of it, choose to employ it, and be successful if they do try and employ it. So I gave a quote by Thomas Homer Dixon, who often says very smart things, but in this one I disagree with him, because I think that's sort of giving in too much without analysis. I think there's an insufficient attention to the process by which terrorists interact with CBRN and emergent technologies, and we have to take into account both push and pull dynamics. Push factors are coming from the actor that lead it to seek out and pursue weapons innovations, and pull factors are occurring in the external environment, as well as the intersection between them. So we then get to the terrorists. So this is the important part. So we've tried to look at the technology a bit. We're now going to move over to the terrorists. So are we dealing with Dr. No, or are we dealing with Fred Flintstone, which was trademarked, so I just used that. The idea is that we're dealing with neither. It's a spectrum like any other form of human behavior. There's a spectrum among terrorists. There's very smart terrorists and very dumb terrorists. There's very capable and knowledgeable terrorists, and completely illiterate and technically illiterate terrorists as well. But we're just thinking broadly about terrorists and technology, and this is coming out of work by people like Bruce Hoffman and Adam Dolnick and Martha Crenshaw and all, a lot of the greats of terrorism research, that traditionally terrorists have tended in their use of weapons and tactics to be both conservative and imitative. Why? Because obviously some of the reasons, these are not all the reasons, but some of the main reasons are terrorists has limited resources, and doing something new takes usually an investment of resources that terrorists often don't have. There are a lot of uncertainties, and that's a nice quote that one of the jihadists posted. I can't remember exactly which jihadist posted, but hopefully it did appear on social media. And then the other idea, so uncertainties mean that you want to actually have an effect. So you might not necessarily try to do something that might not have an effect. And soft targets are plentiful. It's not that guns and bombs have stopped being effective. So terrorists, there's no inherent impetus to drive them there. On the other hand, there are many cases where terrorists have sought new technologies. So why? There's several reasons why they have, including ideological orientation, where they actually do have to counter existing countermeasures. They do have to overcome countermeasures. For status and competition that we heard earlier this morning with drones, a very high level of resources. Some terrorist groups like Hezbollah actually have so many resources they essentially kind of have an R&D shop where they just play around with things. And the last one is, which is directly more relevant today, is costs associated with adopting new technology are lowered. So the technology becomes easier, cheaper, less risky, less dangerous to work with. But the big question then becomes is which terrorists and which technologies? Because we know there's bad technologies out there. We know that most terrorists will not mess with these technologies, but some will. So the key question then becomes, from a policy perspective and from an academic perspective, which terrorists and which technologies will pair up. So to do that, we have to understand the process that I've just sort of spoken a little bit about. But it is a process. And the interesting thing to know about this process is that there's multiple routes to failure, and you have to go through certain gates to succeed. So I'm not going to go, but I've mentioned that before. And there's also an interplay. Oh, well, that's basically what I was just saying. But that's a key takeaway, is don't jump to conclusions about the terrorist threat posed by new technology for CBRN. Just in looking at just the decision to go after CBRN without even thinking about new technology, it's quite a complex decision itself. So we've looked at the new technology, general technology innovation decision. Now we just look at the CB decision. And I don't have time to go into this, but here's sort of a decision tree for how to get to ChemBio examples. So you have to first basically say, make the choice between using unconventional means versus conventional. Then you have to say, I'm going to use unconventional weapons versus unconventional tactics. And then out of unconventional weapons, you have to sort of make your decision amongst those. And there's numerous factors that go into to account for all of these. Again, I'm not going into those because that's a different talk, but that's some of the factors that can lead you to going unconventional. Here's some of the factors that can lead you going weapons versus tactics. And here's some of the factors that lead you towards ChemBio versus RN, for instance. But the point here is that there's a lot of decisions that have to be made and a lot of gates that have to be passed through by terrorists before, and that's just to get whether they're going to go after CBRN, never mind the new technology. So this whole idea is that there's a dynamic interplay of various forces. And to use a horrible academic word, it's equifinite. There's no one path through, but there's lots of ways you can get stuck, but there's no single path through. There's many paths up the mountain to get to the top, to get to that decision. However, there's some sort of broad areas. So just as an example, just like with any innovation, there's risks and uncertainties, and there's often sunk startup costs, and that goes whether you're starting a new company in Silicon Valley or whether you're a terrorist group deciding to go after CBRN. Just like with any organization, you're going to have guardians of the status quo that will resist anything new. Any terrorist organization has those. I've interviewed several terrorists, and I've looked at many organizations, and there's always at least one or two folks in that sort of the old guard. I do get a little bit of extra time for Victor's time, right? Okay, good, just checking. And then you also get the other kind. You always get these new generations, younger generation, as we're seeing with groups like ISIS, who are more comfortable with the latest technologies. As I said, terrorists can be millennials too. So they're more comfortable with the latest technology and often drawn towards them. So there's a constant battle. What usually happens is there's resistance to change, and that resistance gets eroded over time by as the new generations come in and are more innovative and more comfortable with technology. So that's kind of one little example of some of the forces. Now, take a deep breath, everybody. But that's a list of all the different forces and how they intersect. So guess what? The good news is I'm not going to go into all of this. But key dynamics is that it's an intersection between the organizational characteristics, the weapon characteristics, focusing on knowledge. Knowledge is kind of the middle there. And then there's some outside factors like social networks, elements of the society, sort of country-level characteristics if you're a political scientist, and prior adoption behavior, so that's the past. So these all intersect in weird and wonderful ways that we don't have time to go into today, but there is a model of terrorist adoption, weapons adoption. And here's just a little bit about the model, and these are sort of very, very broad looks at some of the effects on the terrorist awareness gate, the decision gate, and the success gate. That's the probability of getting through those gates. As I said, I'm not going to go too much into that, but there are 87 variables, so we can go into that at some time. And I really, really wanted a parsimonious model that had fewer variables, but empirical study has shown that just not possible. Almost every single case has a unique set of variables. So we put everything in the kitchen sink, but don't worry, I haven't run a regression yet on the whole thing. I've tested bits and pieces of it. Here's just an example of how you justify some of these. We're all familiar with, this is not a proof historical example, but this is sort of one of the factors in the model, and the historical example there comes from the early 20th century anarchists and their relationship towards new technology, and that nice quote from them in 1909, where they basically said, terrorism is only really worth it if we use we leverage the most advanced technical sciences of the moment. So that's kind of one factor. If a group succumbs to that view, or espouses that view, they're more likely to be aware of new technologies. Here's a decision example. One of the factors that can lead to decisions, and the historical example here is the IRA, because anyone's been to Belfast, I don't know if anyone's been to Belfast, but they have these you can still see the very tall walls and fences that the British put up to prevent car bombs and to prevent throwing grenades and things over. So IRA had to come up with something new, and they had to come up with something with a steep trajectory, but they could also fire in urban environments. So they on mortars, and that led to the entire mortar program, which I've looked into quite a bit. Here's an example of success. There's something called METI, which comes from Michael Kenny at UPIT, which basically says it's not only your technical knowledge, it's also your experiential, contextual, practical knowledge. And if you don't have that, you're probably not going to succeed. And there's a lot of historical examples of this. Luigi Galliani, they were very, very good. His followers were very, very good at building bombs. They just kept sending him to the wrong place and killing the wrong people, like all the time. And Aunch and Riccio had a lot of resources, a lot of technical skills, but they really just didn't get anywhere with bio. And this is because, one of the key elements they didn't is because they lacked the METI to do it. They had a lot of bioscientists, but not bioscientists with the right kind of practical, contextual skills. 3 elements of the model. I'm not going to go too much. Did I die? Okay, there we go. One of the key takeaways is that don't worry about trying to stop terrorists from knowing about emerging technologies. It's just not going to happen. Even in the 60s and 70s, the case studies that I did, long before the internet, terrorists used to go to the libraries, they used to go to catalogs, they used to do everything they can to become informed if they were predisposed towards this. So the idea is try and stop the very acute technical and contextual practical knowledge that you can frustrate, but don't try and prevent them from becoming aware. It's just going to be a losing battle, especially in the internet age. And here's an application of the model. Once you do it, I compared 3 different organizations, an apocalyptic cult based on Aum Shinrikyo but set in the present, Hezbollah and Q Central, and tested 2 different technologies against IED as baseline. So you could see the technologies were for IED. And for instance, when it comes to awareness, 3D printing or rapid prototyping, Hezbollah sort of was the most likely of those to be aware of it. AQ less aware in the sense that it was an actual awareness of its potential use to actually try and use it. It's not just awareness that it exists somewhere. The decision, though, an apocalyptic cult was much more aware, or quite aware of chemical microreactors. In terms of the decision, Hezbollah again would have the highest probability of doing that, but chemical microreactors, the apocalyptic cult might want to do it. But then when you actually look at success, Hezbollah's got the only one with any kind of success really when it comes to 3D printing, and none of the others would have much success. So it gives you kind of a relative weight. You don't read too much into the scores, but more into the relative scores. And the key takeaway that I want to give from this, and this is one of the key takeaways from my entire talk, is that the terrorist technology dyad is central, not technology alone. So you have to find the salient dyads, not the technologies itself, because there may be some technologies that on their face of it are extremely dangerous technologies. But if there's no terrorist, or maybe one terrorist in the world has a chance, or is even interested in it, or has a chance of adopting it, rather focus your resources on that terrorist group rather than on the technology. On the other hand, if there's a technology that 90% of terrorist groups will be aware of, interested in, and will succeed in pursuing, and to succeed in adopting, that might be something that's much more likely to be something you need to put your effort into focusing on the technology, if it's even possible. Last thing I'm going to talk about, then I'll move on, is the idea of dynamic diffusion over time. So this is the standard diffusion, innovation diffusion curve from Rogers, which those who study innovation diffusion, this is kind of the standard, what they call S-curve. The important thing to know is that there's early adopters. I'll just do this manually. Early adopters are those. You'll see a short, a very slow, very small adoption, and then there's a sudden takeoff. When you hit a critical point of inflection or critical value or tipping point, whatever you want to call it, there's a large takeoff. And the implication of that is just because you see the first part of the curve there, you see a slow, a very slight slope, it can rapidly increase. And that's what actually happens with almost every innovation in any domain. Now, how does this affect terrorism and CBRN? Well, you can look at this in terms of this notion of disruptive innovations. If CBRN, a certain emerging technology, acts as a disruptive innovation with respect to CBRN, you can get tipping points. And on the standard sort of economic analysis of performance demanded with performance supplied, even if the performance provided by emerging technology is still below conventional weapons on some measure, because the very nature of the emerging technology produces a new value proposition, it will actually then become adopted. So without going too much into it, the key takeaway here is that shifts to new technologies by adversaries can be both rapid and permanent. So they're not necessarily going to go 1%, 2%, 3%, 4%, 5%, 6%. They might do that and then jump to 80% and never go down again. And that's what happens a lot. So that's something we need to take into account. So just because we see very slow uptake of technologies by a particular terrorist group or terrorist groups in general, it doesn't mean it's necessarily going to be slow. Now, it also doesn't mean it's necessarily going to be a rapid jump. It depends on the nature of the technology and all kinds of other factors. But we can't just assume that what we see now is going to be the trend line. This is a project I'm going to mention as I'm heading off. It's a project we're currently doing for the Defense Threat Reduction Agency called the IDENT project, the Integrated Discovery of Emerging and Novel Technologies. It's quite a complex project that's combining both human beings, experts, scanning in a game form with machine learning and AI to extract relevant potential technologies, and then filtering that through several models to try and get out of the billions of potential technologies that are out there, try and find what's most relevant in the CWMD space, the combating WMD or weapons of mass destruction space. So we're actually the reason I'm saying this, we're about to launch this. So if in the next couple of weeks you receive an email from me which says, please be part of my system, you'll know at least what it's about. And then another model that we work in we actually call this T3. It was long before you, this is about 3 years old, so I didn't steal from you guys. But terrorist technology transfer, which is a different model, which is focusing on the parts of adoption where there's actually the transfer of technology from one party to another, whether it's from the commercial world to the terrorists, whether it's from a criminal organization to a terrorist, whether it's from a state to a terrorist, or whether it's from another terrorist to a terrorist. And we want to focus on those dynamics, focus on things like the bargaining involved, the middlemen or middle people involved, middle persons involved. And also, how do you transfer both the knowledge and the hardware and the software, so to speak, so the expertise and the knowledge, and they don't always take the same route. So for instance, when we looked at drone acquisition by Hamas, the physical hardware came with a completely different transfer route than the expertise. Whereas with Hezbollah, it all came from the same place. So, this is just a model, there's no time to go into it in detail, but there's a whole lot of bargaining, and we have about 3 or 4 hypotheses at each of these stages, which we've tested about a third of them at the moment. So it's an ongoing work. And the last thing to think about is that whatever I've said today, whatever anybody here has said today, may or may not apply tomorrow, it may or may not apply next year. So this is not something you can sort of write your report, put it away, and say, we're dusting our hands off, we'll come back to it in 5 years' time at the next strategic review. It's something you really have to keep, it's a continuously updating system. You cannot believe how many new technologies appear every single week. I try and look at a lot of these things in the popular science press, and it was published on Reddit and things like that, and there's just so much material. And somewhere in 99.9% of those are going to pose no threat to the United States strategically, but that 0.1% is, and if we miss it, it's going to be really bad for us. So that's, with that, on that happy note, I'm going to end my talk and with something to think about from the great Thomas Schelling, who wrote about this in the 60s, but I think it's as apropos now, if not more so than it was then. Thank you very much.
I am particularly pleased to be here. One of your professors, Larry Rubin, served in our office in the Office of the Secretary of Defense for a short amount of time, and we're pleased to return the favor. And I think that back and forth demonstrates both the importance of the links between various parts of the national security community and the value of this ongoing dialogue. So I'm delighted to be here. I do, though, as Jenna alluded, want to note that I am leaving government service and I'm going to go be an academic. So I'm actually here as in my slowly reanimating academic phase. And so my remarks do not reflect the views of the Defense Department, but rather my nascent efforts to re-enter academia. So I especially want feedback from students, since you're going to be my new customers. I think our remarks are well suited, though. We had a good overview of the CBRN issues, and I'm going to focus on prevention or non-proliferation activities, and he was going to focus on response issues. And so I wanted to talk a little bit about the sort of informal, interlocking non-proliferation framework that was constructed in the post-World War II period to try to deal with the threat of chemical, biological, radiological, and nuclear weapons. And I would say overall, frankly, as a public policy matter, it's been a success. I mean, I think in the with the existence of that framework, we have fewer nations with these types of weapons, and the number of use has been less than it would have been in the absence of this framework. So that's a great thing. But, you know, it's been 50, 70 years since that framework was constructed. And, you know, and so anything starts showing its age over time. One of the things that struck me as I thought about the topic of this conference is as you think about the things that have started to weaken the effectiveness of that framework, two of them are the focus of your conference. I think the emergence of non-state actors, and I think the profound changes in the nature of the relevant technologies are two among the changes in the strategic environment that are having the most powerful impact in weakening that non-proliferation framework. So what I wanted to do today is share with you how I think terrorists and changes in the technology are weakening that framework. And I also want to speculate with you in that the CBRN world does have this experience with a integrated framework of non-proliferation activities, which, as I say, I think on the whole, particularly in the early years, was a relative success. One of the things that's quite fascinating to me is that framework not merely needs to be refined with regard to the weapons it was first applied to, but we've had, I think, interesting discussions today about new technologies. And I think it's an interesting public policy question to ask, does the experience with the CBRN framework give us any insights into the kinds of tools or public policy strategies that could be developed and applied to these new emerging technologies? So those are the two things I want to do in my talk. I guess one thing I do want to ask, and if you'll forgive me, how many folks here are students as opposed to professors, like undergraduates and graduates? Okay, so I have a charge, if I can. I know this will be shocking, but we have not entirely figured out the answers to these questions. And we really need some new, fresh ideas. I think this framework was constructed in a really interesting interaction between understanding of the precise technical characteristics of the technology, and I'm going to try to point those places out as we go through the framework. Things like there is a meaningful, persistent difference between fissile material for a civilian nuclear power plant or for a nuclear weapon. So that's a meaningful technical distinction. So to build this framework, you had to have good technological insights, and you also had to have a good public policy framework to figure out how to leverage them or construct in a multilateral forum this framework. So I would commend to your consideration that I think we do need some creative thought to think of ways that we can apply some of these ideas to the emerging technologies that have kind of bedeviled us in our in this strategic environment, and frankly in our discussions earlier this morning. So does that seem? So that's my proposal. So I did want to talk about the framework, which I think is a very interesting public policy construction, if you will. I'm going to highlight three aspects of it. I'm sure it's familiar to many of you, but one of the things is it had export controls, it had inspections to assure peaceful use, and it had treaties which conveyed norms and prohibitions. So I'm going to sort of talk through it. It's a real alphabet soup, but we'll try to, I'll try to explain it. So first of all, we had export control regimes, which sought to control the sale or transfer of dangerous materials to dangerous people. So that we talked about that in the drone session. It's a persistent ambition. Now this is, we had COCOM, which was the an agreement among sort of the Western states to try to control the transfer of militarily relevant technology to the Warsaw Pact countries. That transitioned into the Wassenaar Agreement. We still have the Nuclear Suppliers Group, which you can understand its purpose. And then there's also the Australia Group, which strives to control the transfer of technology relevant for biological and chemical capabilities. So we do have this framework. And I would point to it is valuable and important, but I think it is being challenged by technology. The diffusion of technical excellence is complicating the effectiveness of these controls. If there's shared agreement about the security threat among all the possessors of the technology, it's a heck of a lot easier to implement an export control agreement than if you have globally diffused technologies. It's much harder to do it. And I think we see most of these technologies, biotechnology, an area where I work in particularly, but also frankly in drones and several of the other ones that have been discussed today, we do see global diffusion of technology. We see lower entry costs. That was a big issue in the drone discussion. It certainly characterizes biotechnologies today. The entry costs are plummeting for most of the capabilities of relevance. And also the dual-use nature of the technology. If you're going to control the dangerous technologies, it helps a lot if the dangerous technologies are clearly different from the technologies that help people. So when we have dual-use technologies, it becomes much more difficult to implement an export control regime. And I guess I would also note, given our discussion today, our focus on terrorists are particularly are often able to elude the state-centered, the state-administered export control regimes. They're often particularly effective at avoiding end-use checks, which tend to characterize the implementation of export control regimes. So again, export control regimes were a great strategy in this non-proliferation framework, but several characteristics of technology and terrorists weaken its effect. But I think we want to think about how whether or not this could be a strategy we could apply to some of our new emerging challenges. I also wanted to talk about inspections to assure peaceful use of dangerous technology. This is particularly notable in the nuclear case. Probably many of you are familiar with the work that the IAEA does. It's quite interesting, I think, the technology that was given to states to use for civilian nuclear energy. In exchange, those countries agree to have inspections of those sites to assure that the fissile material is not being diverted to a military purpose. So that's really the clearest example of this use of inspections to assure peaceful use of otherwise dangerous technologies. As I noted previously, to really make that work, you need to have clear technical distinctions between peaceful, in this case, fissile material, and fissile material that would be appropriate for military use. In my own area of expertise in the biotechnologies, that line is getting narrower and narrower and narrower. And so many of the technologies we're talking about at today's conference are fundamentally dual use. So I think that raises a challenge for these kinds of programs going forward. And finally, I wanted to talk about norms and prohibitions. That's a big part of the non-proliferation framework. They're best captured probably by the Nuclear Non-Proliferation Treaty, the Chemical Weapons Convention, the Biological Weapons Convention. These conventions have slightly different characteristics, but they proscribe use. They can be useful to motivate international action, and they apply opprobrium or criticism to countries using these weapons. Now, we've had some discussion already that terrorists and their motivations are very different from nation states, and so this kind of opprobrium is often less effective against them. So we had I think a useful interrelated set of activities that I think constituted an informal non-proliferation framework for CBRN weapons in the post-World War II period. I believe it was a success, but 70 years later, everybody kind of needs a good renovation, even to apply to the weapons. And then I think it's a useful case study, if you will, for things that might work with regard to some of the emerging technologies we're talking about. And at the outset, I asked for the students to raise their hands because I do think we need some really interesting, creative, interdisciplinary work. I wanted to suggest a couple of areas that I think are rich areas for investigation, both to strengthen the existing framework against CBRN, but also they might have promising leads to apply it to some of these other technologies. So anyway, these are three areas that I think would be rich for inquiry. One thing that I think is an interesting question is how do you, so you want to create norms and you want to create leverage. One of the things I think is most fascinating about the Atoms for Peace project, I don't know if that rings bells, that's really getting deep in the history, but Atoms for Peace was kind of the idea that over time led to the Non-proliferation Treaty and the IAEA. So Atoms for Peace had the basic trade that we will give you the technology for civilian nuclear power if you allow us to come into your country and inspect that you're only using that technology for peaceful purposes. And the thing I've always really admired about that is it created leverage out of thin air. You know, why would these nation states allow the IAEA to come inspect their facilities? Well, because they wanted the civilian nuclear power. So that's interesting to me because it created leverage, and that's what you're always looking for in international relations. It's always something you're always looking for to create collective action. So anyway, I think I commend to your consideration ways to create leverage to solve the collective action problem of enforcing some of these norms that might be effective against drones and continue to be effective against CBRN weapons. Another area that I would commend to folks' consideration is look to shift these areas to being defense dominant. This is a concept that's probably familiar to many of you, but offense dominance, defense dominance, I think is a very powerful concept. The idea is that in certain areas of technology, victory will go to the attacker. So a state might prefer peace, but they probably don't prefer defeat. So if they can only win the war if they attack first, they'll go ahead and attack first. So an offense-dominant area of warfare is very destabilizing. If you can find ways to make these, and I think many of these technologies, I think bio today is very offense dominant. I think many of these technologies are currently offense dominant. See if you can think of ways to shift these technologies to be defense dominant. A theoretical strategy, which I don't think is technically doable, but a theoretical strategy in the bio area would be to create a universal countermeasure. If you could do that, then somebody says, hey, I'm going to attack you with a biological weapon. You say, oh, I've got the universal countermeasure. It's not going to hurt anybody. So then that area of warfare is defense dominant. If you could think of some way to create that outcome, I think it would be very beneficial in all of these technology areas. And then a third area is something I call consider taggants and beyond. Let me explain what I mean by that. With precursors for explosives, we tag the chemicals for law enforcement purposes, so that if you use that precursor, or if one should use that precursor in an explosive, heaven forbid, and it's used and is detonated and causes harm, it's often the case that law enforcement can track back where it was purchased, and obviously that's very helpful. From a law enforcement point of view, in an international context, we would certainly say that that would be helpful from a deterrent point of view. Maybe with biology, maybe with drones, maybe with some of these other technology, there are strategies like that that could enhance the ability to have that kind of deterrent effect. So I really think when one is looking at history, this interlocking, informal non-proliferation framework that was constructed in the post-World War II period for the chemical, biological, radiological, and nuclear field was overall very successful. Not perfectly successful, but I think quite successful. I think it needs to be updated and refined as it applies to CBRN weapons. And I think it provides an interesting case to look at, to identify possible strategies to apply to these other technology areas that we've been talking about. And I do really urge the students and the undergraduates and the graduate students to think about this. This framework was constructed because people had good ideas that were technically informed and that were thoughtful in terms of how to find leverage or how to overcome the collective action problem. And that only can really occur if you have some real understanding of the technology and are able to embed it effectively. So I share that with you, not in the spirit of finished work, but rather we're sharing with you something that really strikes me as one of the great challenges that confronts us in this greatly transformed strategic environment. Thank you.
Can everybody hear me? All right. Let me find my presentation here. Okay. All right, as our excellent conference organizers have said, I'm Dan Kaszeta. I will skip my introduction because skip my bio, which was already kind of covered. I'm into a lot of things. You can, my life is a cheap novel. Feel free to interrogate me later on that. One of the purpose of this presentation really is to talk about technology and capability for response, and a little bit from sort of the glass half empty sort of side of things. I mean, where are we? What do we need? Where are the capabilities missing? Because CBRN terrorism is a technological threat by definition. I take dispute whether it's an emerging technology. We abuse that term. Most CBRN threats are not actually emerging technologies. They're quite old. But that's just a pedantic point. But we rely on technology to provide countermeasures to help clean up the mess afterwards, to deal with things. So this is a bit of a fire hose presentation, and if I have to skip through stuff at the end, I'll be happy to talk to people one-on-one later. Products, technologies, systems, solutions are necessary to deal with CBRN terrorism. We have a lot more things in our toolbox now than we did 28 years ago when I started out in this field. And the capabilities and technologies are improving every year. However, billions and billions of whatever metric you want, dollars, euros, pounds, have been spent on improvement. But no improvement, no capacity or capability is going to eliminate the risk or mitigate every hazard. There's still some gaps here I want to talk about where I think the great capability and technology gaps are. One is in detection, identification, and measurement. It's often peddled as a solution to the problem. If we can detect chemical, biological, radiological hazards, well, problem solved, right? The problem is detection sensors have long been plagued with things like false negatives, false positives. We can have a huge philosophical argument over which is worse, a false negative or false positive. That's neither here nor there. We're detecting living versus dead biological things. We can talk about affordability. There's huge problems in all these things. I mean, a lot of this stems from the fact that detection sensors, detection instrumentation in this field invariably arrives out of defense budgets, defense requirements, which is good because militaries have legitimate force protection requirements, and this stuff more often than not, gets shoehorned into civilian sector requirements. One classic example, if I can make the laser pointer work here. This is a chemical warfare detector. I used to sell these things during my 3-year period at Smith's Detection. The difference between the military version and the police version is the blue paint, okay? And the difference between the police version and the fire department version is yellow paint. Now, fire department responders and police responders and military personnel have fundamentally different requirements. And also, I don't mean to pick on my lovely drone guys, sometimes you have fundamental, misunderstandings of CBRN material behavior. I spent years in meetings where people wanting to put this onto that. Now this is a vapor detector. Basically every vapor that it can detect is heavier than air. So even if you have a very large chemical warfare incident, the chemical warfare material is going to be at or below sort of your mouth level. It's not going to be up in the sky. And nobody's flying a Predator at 1 meter above the ground. It just doesn't work that way. So you can do a lot of system integration and a lot of lovely work to put a DoD JCAT onto a Predator, but it doesn't give you any actual capability. Now, the other problem with sensors of detection, identification, warning, all that stuff, is actually what to do, when it goes off. As I said, they're often sold as an answer to the problem. The issue is what to do when the alarm goes off. This is often easy in a military setting because you have force protection procedures. If you're an infantry battalion, you put out a warning and tell everybody to put their gas masks on. What do you do in a crowded building? What do you do in a stadium? What do you do in an underground subway system? How do you keep this, the funny box that turned up in the mailroom is leaking a funny liquid, from turning into this? Now, earlier in my career, that's exactly what happened when a box of cleaning products happened to arrive at the hangar for the president's helicopters at Naval Air Station Anacostia, leaked, and somebody said, oh, well, let's check it out with our new chemical warfare detection equipment, and it gave a false alarm for nerve agents. So we have basically this within the hour in front of God and everybody at Naval Air Station Anacostia, and my phone ringing up at 2 o'clock in the morning. Should we move the president's helicopters? So, there's a lot that goes on between response and detection, and not everybody has necessarily worked all that out, okay, particularly in a civilian setting. Because sensors in the end are information tools, and they're only as good as the response protocols and the decisions there are based on that. And again, a lot of this plays into public behavior, crowd behavior, and things like that, because in a counterterrorism, anti-terrorism environment, dealing with the public is a huge factor in this. Having this, well, the technical term for this is a goat rope, basically. I wanted to work goats into this thing. This whole goat rope here, this is fine if it's behind a fence and behind a bunch of trees and it's out of visibility on a military base somewhere. Nobody really cares. But if this is on a city street, it's a problem. Okay, it's going to be all over Twitter. Believe me, anything that happens in chemical warfare, it's on my Twitter feed inside a nanosecond. Trust me. Another issue, literally the cleaning up the mess. Economic wide area decontamination. Small amounts of material can cost a lot in property damage, reconstitution, loss of business. It's because decontamination is another one of these things where it's largely been driven by military requirements. How do we clean up an aircraft carrier? How do we clean up a tank? How do we clean up an aircraft cockpit? How do we clean up the skin of a person who's been contaminated on the battlefield? What do we do with the fiberglass insulation in Sergei Skripal's roof in Salisbury? So finding ways to make things clean after an event it's proven to be very costly. And also it comes up against a fundamental, philosophical issue of how clean is clean enough. Because the obvious answer, if you put it to the random member of the general public, is that, obviously zero presence of the hazard. You want 0 molecules of Novichok or sarin, but nobody can detect that low. There's threshold limits of detection for every sort of bad thing out there, and even the best instrumentation, the best lab can't detect single molecules of this stuff in Sergei Skripal's roof. Okay, so you can never know that you can get to that. So basically, there's a fundamental capability gap here in making decontamination cheaper for wide area use, particularly in civilian environments, or else we're looking at property abandonment and all that. I mean, part of this is because the disproportion between the amount of material actually used and the actual net costs. Where if you add up the total cost of the anthrax decontamination efforts and loss of business and all that, the economic effect of the anthrax terrorism, which involved at best a couple of grams of anthrax spores, if that, amounted to about $1 billion. I mean, a good whack of that was loss of revenue and loss of use of facilities and temporary rental space and things like that for the U.S. Postal Service. But a good part of that, hundreds of millions of dollars of that was decontamination of the Hart Senate office building and various, up basically 43 different properties. Another issue is organizational responsibility. This is less of a problem now in the U.S. It was a huge one at the beginning of my career. But the further away you get outside of the United States, where the responsibility lies for chemical, biological, radiological, counterterrorism response is not always clear. In the UK, it lies primarily with the police services. In other places, it relies with the fire services. Some places, it's a military problem. Okay. And it gets complicated in places which are like the U.S., have a federal system, have a dispersion of authority over different levels of government. The problem is in places where it hasn't really happened, organizational authority and who does what and when is not necessarily well worked out unless somebody has really put the effort into it. And there's really only about 15 countries around the world where this has been thoroughly well thought. You have instances like, for example, the Czech Republic, where it's considered primarily a fire department thing, and you literally see exercises where all the forensic evidence is being literally flushed down the drains. You have other places where it's considered a police problem, and people are basically left to die because it's a crime scene, and and you can't let the paramedics into a crime scene. So these things are not well sorted out in other parts of the world. I have to say they're much better sorted out here in the U.S. than they had been. A lot of work has gone in on that, and only because people like me early on in like the mid-90s are saying, "Hey guys, wait a minute, this is kind of crazy." Another gap, this is one of my pet peeves, one of the areas where I do have peer-reviewed work on, forensics. Responding to the problem, decontaminating things and taking sick people to the hospital and making them well is all important, it's all very good, but if you're going to actually do prevention of further things, you want to actually catch who did it. You want to catch the bad guys. And this is an area where the further you get out of what I would call basically the Five Eyes Anglosphere, the further you get out of that, the problem gets more obtuse. You need to, if you're going to have rule of law and prosecution of criminal cases, and by definition, terrorism is criminal acts of violence. If you're going to prosecute perpetrators of these events, you actually need evidence. If nobody can process the evidence in an efficient and effective and forensically sustainable way, because nobody can collect the samples the right way, you might have the guilty guys go free. Part of this has to do with the fact that a lot of the evidence in the CBRN incident is actually conventional evidence. What if there's an iPhone covered in persistent nerve agent? Well, guess what? The electronics laboratory that can exploit that iPhone is not going to be able to handle the fact that it is covered in nerve agent. Likewise, the very lovely military CBRN lab that can tell you that it's covered in VX can't exploit any of the data on it or extract a fingerprint off of it or anything like that. This is a huge problem. It's one of the reasons why Interpol is actually setting up a task force that's starting next month, and I got dragged into it myself to try to set up some basic standards on this. And it's an area, again, where the U.S. really had some problems with in the early 90s, trying to deal with it philosophically, has worked through it. Other places are a lot further behind. Until you have to work one of these cases, it's kind of theoretical. I mean, one of the reasons why there's been good casework, good forensic work in the UK on the Skripal case is because a lot of stuff fell through the cracks, and a lot of forensic work was really kind of speculative during the Litvinenko poisoning in 2006, and there was a big learning curve between the two. Public resilience is an area here. This has been mentioned on before. Things like within the CBRN community, within the sort of the CBRN silo or ghetto, whatever you want to call it, that I normally work in, not necessarily with you guys. You guys are good, you're generalists, you start to look at things from a lot of things. You've got a lot of social scientists. I go to meetings full of chemists and chemical engineers. okay, and explosives guys and stuff like that. You know, in my normal circles, people are just starting to deal with human factors and social and psychological stuff. They're just now starting to talk to sociologists and anthropologists on how people actually behave, as opposed to sort of cartoon, you know, caricatures of how people behave. Things like crowd behavior, online behavior, lack of education, all really mess things up. I mean, one example is particularly relevant here. I'm just going to pick on the vaxxers because I can. I will no doubt get no end of hate mail on this, but you know, I mean, a fundamental countermeasure against many biological warfare threats is various types of vaccinations. This is how, if somebody uses smallpox, we're going to fight it. Okay, if you have refuseniks out there refusing to take anthrax vaccine or refusing to take a smallpox vaccine based on whatever flawed belief system they have, it's going to be a detriment to public resilience. And I don't need to harp on that. I think probably everybody's with me on this, but these things all factor into it because because of the risk perception, people have both a flawed and disproportionate perception of reality when it comes to chemical, biological, radiological threats because most people are not terribly well informed in the fine details. That's one of the things I keep coming back to again and again. I mean, I have fundamental arguments on Twitter whether sarin gas is actually a gas, and it's not, it's a liquid. And don't even get me started on mustard gas. You know, if people can't understand that mustard gas isn't actually a gas, then, you know, getting into finer things like, you know, incubation time of anthrax spores, you know, it's kind of lost if you can't, you know, you get the basic stuff right. So, if you're in an environment where, you know, there's widespread just lack of knowledge, then all these human factors are just going to make any kind of response much more complicated. Yeah. All right. And again, because one way or the other, I inadvertently woke up one day and found myself king of nerve agent Twitter. The disinformation, information warfare aspects of all this are important. I just want to say, I mean, you have to assume that either one of two things are going to happen, you know, in the event of deliberate CBRN terrorism, probably both. You're going to have deliberate disinformation being spread to obscure what goes on, and you'll have some sort of organic baseline of just sort of homegrown misinformation that goes on that complicates the response environment. If you look at what happens every time there's a chemical warfare incident in Syria, this happens. You look what happened when Sergei Skripal and his daughter Yulia got ill in Salisbury, only about 100 miles from my house. You know, the information environment got very, very warped very quickly, and very much so on purpose. Again, there always be organic conspiracy theories, for lack of a better term. There always have been. They've been old as the hills. The problem is with social media, they spread. You don't have to go to dodgy bookshops in a weird part of town to meet like-minded weirdos. You find them in 5 seconds on Twitter. But also, conspiracy theories are deliberately spread as well. And bad information, whether it's misinformation, which is just, you know, people are just wrong for whatever reason, or disinformation, people being wrong on purpose, this acts as a multiplier, a force multiplier for terrorism. You know, the idea, you know, for example, this is just 2 tweets out of my vast catalog of these things. You know, I actively discourage anybody here from following me on Twitter, except Mia. You can still follow me on Twitter. Everybody else should just block me on Twitter for their own sanity. Because I go to war on a daily basis with this stuff. But, you know, this stuff is dangerous. It's hazardous. It complicates the response environment. I don't have a ready answer yet for this. I just want to, you know, like my predecessor here, I want to put this out as a line of inquiry. That finding ways to grapple with the disinformation and misinformation out there is extremely important. Now, on that note, I think I'm done. There's my wretched Twitter handle if anybody wants it. Thank you.
So I'm here to not have the mic.
You can turn it on.
Oh.
Screen. It's got the screen.
So I'm here anyway to conduct the Q&A for the remaining time. We're about 15 minutes left. One quick thing I actually wanted to kind of say while you guys get ready for the question is what we kind of see from this is a need for a framework to how to deal with what these technologies, and the previous frameworks didn't necessarily do that. How do we think about a lot of these things? And one of the things that reminded me of what Carol highlighted was something that I happened to work on in that office back at inception called the Proliferation Security Initiative. And now it's what this initiative is. It isn't a treaty. It's about sort of almost a sense of power of norms or coalition of the willing to mitigate the threats of weapons of mass destruction and related materials. But at the time of its inception in 2003, probably Dan was certainly working in government at that time. It was much more about the threat of non-state actors, particularly Al-Qaeda, getting weapons of mass destruction. And this is what drove this. And now it's kind of shifted a bit, but maybe we need to rethink how these types of international, they're not necessarily an institution or some type of regimes or things can reinforce those norms in a certain sense of the pressures on states to do more within their capacities and national authorities. So with that, I'm going to turn the floor over to questions from you guys. And if not, I have my own, but I'm going to hold back on that. Okay? Yes, sir. Yes, sir.
Thank you. Thank you so much. This was extremely insightful. I know that when we distill down the collective threat of potentially terrorists acquiring CBRNE type of weapons, it comes down to possibilities versus probabilities. And we know that possibilities have vastly more variables than probabilities. But in my recent research, just looking at terror actors who are in support of Al-Qaeda and ISIS, if you want to call them lone actors at home sitting in front of their internet screens, researching biochem weapons. There is I don't want to say proliferation, but there's a growing distribution of content that's repurposed from old research and new one, and put together with really beautiful glossy cover, and to say we, for example, a Sakri Media for Warfare Studies that supports ISIS, let me put out all of this research out. And one of the documents that was put out that I came across just last week, and I wasn't familiar with this, but botulism bacteria, which could be fatal and derived from toxins, that you can apparently easily extract that poison or that toxin, but I guess it comes down to the weaponization of it. My question is it all about the mechanism of delivery? Is that where the danger really stems? Because the information is available everywhere. It's just the delivery mechanism might be the difficult part. So I would love to hear your thoughts, any of you and all of you, on that. Thanks.
I'll jump in real quick. And like Gary said in his presentation, there is a vast pathway between idea and implementation, and I should say successful implementation. And think of this as a highway with lots of off-ramps and only one off-ramp at the end that leads to actual successful use. Okay, and the history of CBRN development programs at state level, non-state actor programs is replete with all kinds of people crashing off various off-ramps, okay? And often taking sort of a decade or more to get from the beginning of the highway to the successful implementation, with a lot of expenditure, a lot of deaths of your own people, and a lot of interesting failures along the way. And these interesting failures in a counterterrorism environment being the sort of thing that get you noticed. Now, the way to look at this is sort of, depending on the material you look at, sort of the length of the highway differs, but the number of off-ramps is about the same, okay? Now, if I was to rank these things from easiest, absolutely easiest thing, the sort of shortest length of highway, to the longest, Botox is probably the sort of the second shortest after about ricin, but it's got plenty of pitfalls, okay? And one of the, again, as you already hit on it, one of those pitfalls is actually weaponization. Botox was heavily explored by the U.S. Offensive Biological Warfare Program, and not with great actual field success, I should say.
I'll jump in here. So it's a very interesting question. So I've got three sort of responses. The first response is to talk about the Botox itself. As you create, it was explored by the superpowers and by various other powers on how to weaponize Botox. And the thing is, it's a very fragile molecule, and it doesn't last very well in the atmosphere. So aerosolizing it is not that easy. You can still use it for poisoning, but aerosolizing it is difficult. However, and I will say this, in the last year, they've actually come up with synthetic lipid containers, micro nano containers, that you can put a Botox molecule inside that will protect it from all the atmospherics that would have messed with it the first time. So I'm actually saying that all the literature you read on Botox says it's not a mass casualty threat. I think that emerging technology might actually be making it a mass casualty threat, but mainly at the state level. I'm not worried about it so much at the terrorist level, because no terrorists are doing micro-encapsulation or nano-encapsulation now. So that's just about the Botox. In terms of the jihadists, we did a tracking starting in 2002 about the CBRN things that were appearing on the websites. And it was interesting to see, because in the beginning, now we must distinguish the fact between what they have at what a Al-Qaeda or a ISIS fighter expert is doing in a lab somewhere is very different from what people are posting online. Now, it may be equally as bad, but it's going to be different. So when I'm talking about it, this is what the generic kind of milieu is aware of. And it started out in 2002, 2003 that it was a joke. They put things up there that was completely wrong. Creating a fusion bomb in your bathtub, there was a recipe. There was to try to make an RDD that, I would love it if they made that RDD, because it probably would have had more people killed by the flying chunk of radiological material than any kind of radiation. So it started getting better. And about 2005, 2006 started getting a lot better. They started going to scientific journals. They started going to older materials, translating them to Arabic. They started getting hold of some Iranian materials that the Iranians had taken from Farsi into Arabic for Hezbollah, and somehow that got into some of the Sunni jihadists milieu, started using that. So that started getting more concerning. It was still not at the level of weaponization, but it started getting concerning. It started getting more concerning when what they actually started doing is taking right-wing manuals, a lot of especially the rice and stuff and the Botox stuff from the right wing, and translating it directly into Arabic, which was kind of hilarious, because some of the right wing, they also translated some of the right wing ideology, which was, it got very funny on time. However, the key thing, as you said, is weaponization. That's the key thing. Many of these agents can be obtained, at least in a very crude form. The problem is, if you really want something to have an effect that's more of an effect than a gun or a bomb, you've got two choices. You can, if you want it to have a physical effect, that's more than a gun. A psychological effect, that's a whole different story. But a physical effect, you're going to have to weaponize it in some mass way. And that's where it gets difficult. Now, it isn't impossible. We have a data set of 400 CBRN terrorism incidents, and 200 of them were successes and 200 were failures. So it's a 50-50 rate, which surprises us. There's selection bias in that, because we might not know about a lot of the failures, because nobody ever talks about failures, but we do know that there's at least 200 successes between 1990 and the present. So to what degree were they successful, that varies, but 200 successes where they actually got something that could actually hurt people. So it's difficult, it's not impossible. So I don't know if that helps, sort of answer that area of things. Okay, so next question.
So I have two questions. The first one is, maybe Carol can answer these questions. So we know there's intangible technology transfer issues. For example, by sending out just blueprint for the centrifuge, and then non-state actor or some proliferating country can make the centrifuge from the indigenous without actually transferring the physical materials and so on. So what is your answer? I mean, how can you deal with those issues in the future? And the second question is, what kind of positive incentive can be given to developing country for the promoting export control you think is important? Because when you have some outreach activities in Southeast Asia, especially, like even though the Security Council Resolution 1540 was adopted under the excuse for, purpose of the preventing like a proliferation by non-state actors, still the way export control regime is functioning is same. And then from their point of view, economic development is more important than like non-existing potential threat by non-state actors. So it's actually hard to convince them to like put lots of resources for the regulation function rather than economic promotion. So.
No, I think that's a very interesting question. The issue is to what extent can developing countries or should developing countries be encouraged to adopt and energetically implement export control regimes? And I think that's a good question. One of the realities, and I'm sure each of you recognize this, is there's limited fiscal resources, but also, frankly, there's limited bureaucratic resources to pursue initiatives. And so you really, have to decide what's the high leverage step. Larry, I thought, raised the example of PSI, which I think is a very, very interesting case. The Proliferation Security Initiative was an effort, as he noted, that's sort of a coalition of the willing. And it was not preceded by detailed negotiations. They didn't have plenaries and working groups that developed a document that governments then signed. They just sort of got a small group of people a small group of countries to agree to take certain kinds of actions to stop the further proliferation of items of concern. And then they just persuaded additional countries over time to join the group. It's an interesting, again, I'm interested with the idea of which of our previous efforts at non-proliferation activities could be usefully applied to these new challenges of emerging technology. And I find the PSI model intriguing because the investment of time and energy into securing that group was much lower, and yet it's really had beneficial effects over time. So that's intriguing to me as possibly a new model. Your question about export control regimes and to what extent we should seek out the energetic implementation of them by developing countries is an interesting question. If one was in the government and you were trying to decide, am I going to send demarches to Addis Ababa, ask them to really go demarch the government, you want to ask yourself, what specific benefits do we see? If they don't have advanced technology, then maybe it's not as high a priority to have them build a robust export control system. Maybe what we'd want them to do is construct national laws with certain characteristics regarding the handling of certain technologies that are dual use, but if they were used for military purposes might have particularly egregious effects. So you not merely have to identify things that would be beneficial to do, but you're allocating very scarce resources from a government point of view of fiscal resources and bureaucratic energy. And so what is not only a useful thing to do, but what is the highest leverage thing to do to advance your objective with regard to these emerging technologies? And what's intriguing about the emerging technologies is they're so different because of the low entry cost and the global diffusion of technical excellence. But I think you're asking just the right question as you look to the future.
I mean, when you get into international forums, you get out of the sort of developed world, you get out of the North America, Europe, Japan sort of sphere, and you get into the Middle East, you get into Africa and Southeast Asia, Latin America, through things like Interpol, the EU's CBRN Centers of Excellence program, a lot of the stuff Dietrich's doing, you get this sense that this is, not to put too fine a point on it, this sort of CBRN stuff is, that's a sort of rich white country's problem, it's well down in everybody else's perspectives in a lot of places. But it is until as the saying goes, it is till it isn't. Ethiopia is an interesting example. they don't make a big fuss about it because it becomes a big thing every time they dig up an Italian mustard gas bomb. They do very well to keep it undercover, but all of a sudden, for about 48 hours, the Ethiopian government gets very, very agitated about chemical weapons stuff, and then it goes back to not being terribly important again.
Well, we've come to the end of this period. I have to add one other thing about PSI, and that has to do with actually the issue that was developing there had a lot to do with intangible technology transfers, in particular when I was last working on it, and specifically having to do with looking at some of those technologies that would spread. They had to do with states, but a lot of times thinking more specifically about non-state actors and groups. So I'm glad that you brought it up, and I'm glad that I got to plug this thing I used to work on. But there are a lot of those applications, and they certainly can come back, and I think that's the general point of how should we think about some of these technologies in the future as opposed to non-state actors, and maybe we need to rethink some of the previous frameworks we have and kind of refine them and reform them. So with that, we are actually perfectly on time. We're going to take a 15-minute break and then go to the next panel, which is AI, technology, terrorism, and continue the rest. And we'll move forward from that. And at the very end, as you all know, we have the keynote address.